Hello everyone. So today I would like to share about a problem I've run into in the previous coding test of Roblox. And the challenge is called build offices. So to build this problem will give in fact he will not give a map. He will just call you can find a map and he will give you the width and height of the array, which is also the map, the size of map, and you need to build the n of offices. So this, if n equals to 3, that means that you need to build 3 offices in the map. Okay, so just like this example, 0 in the arrays means the place you build up the offices. And so this one in the array means that offices is far from it with the distance 1. And this, when this equals to 2, it means that the nearest office come to this place need to go 2 steps. So this one we can find that, okay, we need to go 1 step. And this one we can find that we can go from here with 2 steps. And we can also go from here with 2 steps. Okay. And in this case, we need to return 2 because uh, we need to return the farthest distance in the map. So, however, uh, the problem didn't give the list map. How does this map look like? He just want us to return the optimal solution. He want us to find the optimal place to build up our office that we can find. Uh, we can find any place. We can visit any place in the map with the shortest path. Okay, so when I faced this problem at the first time, uh, I feel so confused that because uh, when it comes to face the problem of shortest path, I always want to handle with shortest path breadth search. That would be the best solution to handle the shortest path problem. However, this problem didn't give us any hint of the map, so I don't know how I can find the shortest path to visit all the nodes. But in fact, the key point of this problem is that here. This means that the place which can have a building, no matter you want to build offices or the nodes you want to visit, all the slots of the map is smaller or equal to 28. So it means that if we can use brute force to list all the cases of the slot of the offices we want to build with. So take this as example. If we want to, I will write this down. Let me draw on. Okay. Okay. So okay. So this width have 4 and height have 4. It means that here is 6 nodes in the map. Okay. And we want to build 3 offices. So we can find any place to build our office, such like maybe I want this one and this one and this one. So if we want to use brute force, how much how much kind of solutions can we use on brute force? It must be C16, and we get 3 places for randomly. Okay, so maybe how much is 15 and 17? So it's still just hundreds of ways to run all the solutions for brute force. So it still not get so much time complexity. So due to the fact that uh, the most lot is 28, so mm, we don't need to worry about that. We cannot list all of the case and to find the shortest path on it. So the solution become very simple. We just need to list all the cases that we can build, all the cases, and we just need to find the shortest path from all the cases of the office building. And then we just need to compare the results. Then we can find the the max distance of the optimal solution. That's all. So next question is that what is the optimal solution? Okay. So take the map on the screen as example. If we want to visit all the nodes on the map from the offices, where do we want to build our offices? I will use red pencil. So if we choose 3 offices and we build at here, 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 okay, this must not be our answer. This shouldn't be our optimal solution because if he want to go to this place, then he will need to go 1, 2, 3 step. And this is still not our answer because if he want to go to this place, then he will need to go the nearest office must be this one, right? And he will need to go 1, 2, 3, 4 step. So we need to return 4. However, if I use here is blue man. Mm, if I am a blue man, I will choose to build our office at this place. First office at here, and maybe second office as here, and third office I may be built at here. Then how do you think the answer would be? Okay, this answer will be 3 because take maybe this as example. If you want to visit this node, you can go from here, this office, and you can also go from this office. They both need 3 steps to go to this node. And from this office, this also needs 3 steps to go to this office. And if I want to visit this node, I just need 2 steps. And from this office also needs 2 steps. So now we can find out maybe the optimal solution is we can build our offices maybe don't too close to each other. They can be a very average place on the map, and to make they go to each node can be shortest paths. So Here, my solution is to, the whole is 16 slots, right? And 16 slots, I will divide it by 3, and I will get 5 by 1, right? So I know that when each 5 slots, I will build up at least one offices. So only one offices in each 5 slots. This will be optimal solution. So let us see what this means. Each 5 slot from left outside. So one, one, 2, 3, 4, 5. This is first 5 slot. So I build at here. And 1, 2, yellow one, 3, 4, 5. I build up second offices. And the last 6 slot, I will also build one offices. This will help me to get a optimal solution. Okay. I think it will be very easy to find the optimal solution if you draw the map and you can look how you can get the shortest path to visit all the nodes on the map. Okay. So now what will be our solution? So I will use first I will use brute force to list all the possible case of for our 0, which is our starting point. So to do the brute force, I will use DFS search. Okay. After I use DFS search to list all the starting point, I will use such like I start from one starting point. I will use prefer search to do shortest path to update the distance on all the nodes of the maps. So how to upload all the distance on the maps? We just need to use label ordered prefer search. Then it would be very easy to get our final distance. And then we have many brute force case, right? To start from different start point, and we just need to compare the result from preferred search of the max of the shortest path. Then we can get which one would be our final solution. Okay, so this is my code. It seems so long, but in fact, it's very easy to understand. Start from here. I will use two-dimensional map. This variable is used to show the graph that I just draw at such like this one. This is just like a map. Okay. And so here, edge and height and width. Here is mean this is height and this is width. Okay, and I will set initial value as a very big value. And here is start point. Start point means that I will store the all the possible cases for our start point in this vector. And so this is just the coordinate that will help me store x coordinate and y coordinate, which is the position of the start point. Okay. And then I start DFS search. DFS search help me to list all the possible case of the start point, which is 0. Okay. So here is the part of the DFS search. And okay. So what is D? What is this parameter? So I'll just say that if I want to find the optimal solution, I will use 16 to divide it by 3, right? And I will get 5 by 1. And I will try to build up one of these in each 5 slots, right? So D means this 5. Okay. Okay, so here you can find that I use this slot divided by n and I can get d at here and pass into the depth search function. And this will show because we need to start from what visit from all the offices, right? So first n's underline shows that currently I start from whether maybe the first start point or second start point, and the second n means that the whole number of starting point. So when n underline equal to n, that means that I already visited all the nodes from the all the start point. So then I will leave depth search. So this means that I have already visited all nodes. Then I can start to summarize and analyze that whether my max distance is smaller than the other's result. And here I will store other result as a global variable, which is called max distance as here. Okay. So now how to um, how to find all the possible cases. This is a very easy cases of backtrack. Here, uh, so here, first, I will list I0 from I to D. So this means that, so if we try to make our, such like, this is our map, right? Then we can numberize it as 0, 1, 2, 3, 4, 5, 6, 7. Then if we try to flatten it, it will become a line of 8 elements, and it will become 0, 1, 2, 3, 4, 5, 6, 7. And if we have 2 offices to place in this 8 slot, so 2 offices will become 4 by 0. And so we now D is 4, right? So I will choose to put first offices in first 4 slot and second offices in second 4 slot. So this is what I mean at here. First, I will iterate the first 4 slot and put my first offices. And which coordinate correspond to in the map. So we just need to it will be easy to understand if I choose this as example. If I want to put offices at this place, which is number 5, Then how do I change it to the coordinate in map? In map, is in fact to be map uh, 1 and 1, right? At this place. So how do we calculate this result? We just need to 5 divided by y. And we will get our result of x and by y. So this is how I do these things. Position divided by y, and the remainder becomes the y coordinate. Okay. And next we need to this is our I consider this as our start point. So I also need to store it into our start point vector. So here this is first start point. So I will put it into the coordinate, and I use pair to store it. So here I will use first and second to access the element in pair. Then again and again to try to find the first office's place and second office's place and the last office's place. And at finally, when we choose all of the possible cases of offices, then we can call breadth search. This means that you already decide all the offices placement in the whole map. Okay. So now let us take a look at breadth search function. So this breadth search is very classical that everyone should know how to do to find the shortest path. The only thing you need to care about is that because you want to calculate the distance to visit whole map, so you need to do level ordered breadth search. So here, I use a queue. We always need to use a queue to maintain the order of the breadth search. And then after putting we need to iterate each neighborhood of the node in the queue, right? So here is the neighborhood, and I also need to check whether this neighborhood existed. First, check valid is my defined function. So here, check valid. So first, if condition means that if the coordinate is out of bound, then return false. This is not valid place. And the third one, you need to check whether you have visited this node previously, or the time complexity of breadth search will become more and more serious. So if there no any case return you the false, then it means that okay, this neighborhood is valid. Then you can visit this node at the next time. So I update the distance and also put the value of the distance in the map. Okay, so here another problem need to be care about. When I use pair style as our data structure, so I need to uh, see whether this position have been visited by our breadth search. But you cannot put pair type in the set because just like here, you can see that there will be a compilation that error when you try to do this such kind of things. In, especially when you try to use unordered set or unordered map, because there is no hash value for key in uh for such like pair data structure. So here I use another way to store the coordinate in visited set, which is integer. So how do we convert x coordinate and y coordinate into the integer based, just like I teach here? You just need to flatten the map, then you can use a decimal based position to store each place. So here, this is how I calculate the unique value for each position. If in original two-dimensional map is at the place of 1, 1, and I just need to uh, multiply with y and add the y coordinate, and I can get the number in stored in visited set. Okay, so here is just the preference search part. And after I get the preference, after I finish the preference search traversal, and I just need to visit all the nodes, visit all the distance stored in the map, and see which is the max distance in this map. And then compare with other value in other maps. Maybe in other cases, max distance is different, but I just need to check after preference search whether my return value is smaller than current max distance, which is other map value. And if it is shorter, then maybe here's the answer what we want. Okay. So the code seems so long. However, it is very simple problem that we just need to brute force for all the cases and try to brute force is built by depth search and use breadth search to find the shortest path. And so even you don't need to use the optimal solution such like this one, and you still can find the final answer. So I just try to prune some duplicate cases that we don't need to talk about in my depth search on starting point. So this is how I handle this problem. And if you want to see the code, I have already write down the final solution in big Stack Overflow for you. I have passed it at here. If you are familiar with C++, I think this answer can help you to understand final solution with easier way. So I will also share this link in the comments under the video. So good luck.